Okay, so now let's look at a couple of questions here. So the first problem, it asks us, write the set denoted by the shaded area. Okay, so this is graph. As you can see, the shaded area has two parts, right? This is the first part, and this is the second part. So what we can do is we can write down the first shaded area and then union the second shaded area. Okay, so look for this one. So do you agree that to get this part, it's gonna be C subtract A, right? And then subtract B. That will do the work, right? So that's gonna be this pieces. And then I'm gonna have a union about this part, right? So how do we get this part? Well, actually you can think about it, this part, which is the A intersect B, right? And then if you have this A intersect B, after that you subtract C to create only this part left. So that's how things work. So we're gonna have it's A intersect B, which is give us this pieces, and then minus C, and that will do the work. Okay, that will do the work. So this is how do we do the first problem. Okay, now let's take a look at the second problem. Okay, so let me move above. Okay, and you can read about it. It said that we have two teams. Okay, A and B play a soccer match, and we are interested in the winner. So the sample space can be defined as this set has three elements: A, B, and D. A is the outcome, show that A is gonna wins, team A. Okay, B show that the team B wins, and D shows the outcome that they draw. Okay. Suppose that we know the probability that A wins is 0.5, and the probability of a draw, which is 0.25, right? So find the probability that B wins. Okay, so as you can see here, this set A, B, and D, and those three actually can form a partition for my universal set, right? Because the union of them, it will construct the whole sample space, while for each of them, it's going to be disjoint. So in other words, so for part A, we know that the probability of A plus the probability of B plus the probability of D equals 1 based on the X sum of the probability, right? Sum of the total probability equals 1. So hence, it's very easy to drive that the probability where B wins is going to be 0.25, right? And then the second one is find the probability that B wins, or we have a draw. So that is what? That is when the event contains two elements, right? Either it's B or D here. So here. And noticing that those two are disjoint, so this give us is a PB plus PD, which easily equals 0.25. So that is very, very straightforward. Okay, that's number 2. Number 3, it said that, okay, we have the probability of A equals 0.4, probability of B equals 0.7, and probability of A union B is equal to 0.9, right? And then it asks us to find all of the following parts. So first one, find the probability of A intersect B. Well, noticing that A and B definitely it's not disjoint. Why? Because you can see that P A union B does not equal to PA plus PB, right? So we could apply the inclusive exclusive principle. So part A, we can have P A union B equals PA plus PB, and then minus PA intersect B. So we draw it's 0.9 equals 0.4 plus 0.7, and then minus PA intersect B. So it turns out we can derive that PA intersect B equals, so this is 0.2, right? Equals 0.2. So that's part A. Part B, it asks us to figure out the PA complement intersect B, okay? And the PA complement intersect B basically is equals to PB minus A, okay? Or you see, if we draw a Venn diagram, and then as you can see that suppose this is A, this is B here. So A intersect B is 0.2, right? So probability of B is 0.7. So this part is going to be 0.5. And the similar, this part is going to be 0.2. So of course, this is the whole sample space. This is going to be 0.1, right? Because all of them equal this. Hence, what is P A intercept A complement intersect B? As you can see, it's this part, or B minus A, right? So it's equals to 0.5. Okay, it's equals to 0.5. Or remember that B minus A equals to P B minus P intersect B. So you can also derive this is 0.7 minus 0.2. We derive all from part A. It still gives us is 0.5. Okay. Part C, it asks us find the PA minus B. Okay. So A minus B, as you can see from here, so it's equals to 0.2. Okay, once we have this Venn diagram, things becomes very straightforward. D, P of A complement minus B. Okay, so as you can see that this is A complement, right? This is the whole A complement here. And if you minus B here, do you agree that it's just the part of this pieces, which is equals to 0.1. Okay, is equals to 0.1. Okay. Okay. And Problem E, it's to find a P A complement union B. So A complement is right here, and then union B, as you can read about it, it's A complement, it's all these pieces here, okay? And then if you have a union of B, which basically is adding this part, so it's three pieces, this pieces, and this pieces. So as you can tell, is equals to 0.8. Okay, is equals to 0.8. As number F, the probability of A intersect B union A complement. Okay, so B union A complement. Okay, what is it? So this is our B, right? So if we draw another one, so this is B, this is A, okay, this is B. Let me draw it here. So A complement which is this part, right? Which is all this part. And then union B, do you realize it's this pieces, right? And if you have an A intersect this part, realizing that that's exactly this pieces. So as you can see that, so this pieces here basically is equals to probability of A intersect B. As we already derived that from part A is equal to 0.2. Okay, is equals to 0.2. Of course, there is another way to think about this, which remember that you have the distribution law, right? So probability of A intersect B union A complement, it equals to the P A intersect B, right? Remember union A intersect A complement, right here, right? But what is A intersect A complement? Don't you agree? This is the empty set, right? So it gives us is the P of A intersect B union the empty set. So still we can derive this equals to P A intersect B, which is still you know that this equals to 0.2. Okay, this equals to 0.2. So those are the first three examples, and I'll stop here and thank you for watching.